The Snowball Earth hypothesis proposes that Earth's surface became almost entirely frozen during the cryogenian period from about 850 to 630 million years ago. In 1964, Brian Harlan proposed that a global-scale glaciation had occurred before the Cambrian period. He based his conclusion on paleomagnetic data showing that glaciers had existed at tropical latitudes. The petrified glacial sediments on opposite sides of the South Atlantic Ocean provided early evidence for continental drift, and they also provided support for the Precambrian Snowball Earth glaciation hypothesis. In 1969, Mikhail Budiko, a Russian climatologist, published an energy balance model to calculate the effect of ice cover on global climate. Budiko's model predicted that if the ice sheets advanced far enough out of the polar regions, the increased reflectiveness of the ice led to further cooling until the entire Earth was covered with ice. The physical evidence and the computational model firmly established the Snowball Earth hypothesis. The world was very different at the time of the Snowball Earth. The supercontinent Rodinia formed about 1,100 million years ago and was the dominant landmass for about 350 million years. Geologists generally agree that the east coast of present North America, called Laurentia, was adjacent to western South America, which then consisted of the Rio de la Plata and Amazonia cratons. The west coast of North America lay next to what is today Australia and Antarctica. Rodinia broke apart during the cryogenian period from about 750 to 600 million years ago to form the Pan-African Mountains in a new supercontinent called Pannotia. The cryogenian period from 850 to 630 million years ago included the breakup of Rodinia. The Snowball Earth freezing event caused the mass extinction of 70% of the dominant algae-like sea plants 650 million years ago. The cryogenian period was followed by the Ediacaran period, during which the supercontinent Pannotia was formed and the first multicellular soft-bodied organisms appeared. It is thought that Snowball Earth thawed out as a result of volcanic activity, which added carbon dioxide to the atmosphere and increased the greenhouse effect, but the cause of the glaciation is not known. Several ideas have been proposed, such as the decrease of carbon dioxide in the atmosphere by the formation of carbonates and by the photosynthetic activity of cyanobacteria. Also, the runaway cooling effect of increased ice cover on the Earth has been considered because ice reflects 85% of the sunlight, whereas open ocean reflects less than 10% of the sunlight. Other possible causes for the Snowball Earth could have been the increased tectonic activity from the breakup of Rodinia, or the catastrophic effect of an extraterrestrial impact. The idea of an extraterrestrial impact as the cause of the Snowball Earth has not received much attention. The Aïr Mountains in Niger have some interesting circular geological features that could have been caused by impacts of a cluster of comet fragments. In 1974, Rudolf Brunschweiler determined that the Aïr Mountains have an oldest date of formation of 660 million years, which is approximately the time of the cryogenian extinction. The overlapping rings of the Aïr Mountains can be explained as the result of impacts by a dense cluster of meteorites rather than as the result of endogenic geological processes, but the site has substantial evidence of volcanic lava that could have been triggered by the powerful impacts of the cluster of comet fragments. The Aïr Mountains have been described as granite intrusions of Precambrian origin by several authors, including Brunschweiler. In 1994, Moreau and three co-authors claimed that the ring structures in the Aïr Mountains are of more recent origin and attribute their formation to a major magmatic event in the Paleozoic era. How is it possible that mountains with elevations from 900 to 1,700 meters above sea level could be the site of an extraterrestrial impact? One possibility is that the impacts were concentrated in a small area and they were vigorous enough to crack the Earth's crust and trigger volcanic and tectonic activity that raised the landscape. This image highlights the circular structures of the Aïr Mountains surrounded by fields of lava that created the mountain range. Notice the distribution of the circular areas from the top to the bottom, which is reminiscent of the trail of impacts left on Jupiter's atmosphere by pieces of the Shoemaker-Levy comet in 1994. This is a detailed view of the major cluster of overlapping circular structures. Higher resolution images can be obtained from satellite images of Google Maps starting at latitude 18.8 and longitude 8.8. The largest of the circular areas, labeled as Circle 5, has a diameter of 60 kilometers. The northwest edge of Circle 5 is a very prominent circular arc, and its southeast edge is faint but distinct. The western outline of Circle 5 has been degraded by erosion, but some traces of the circle are still visible. The combined energy of the impacts that created these circles is equivalent to 2,220 megatons of TNT, which is comparable to the energy from the impact that ended the era of the dinosaurs. In addition, the disintegration of a comet as it entered the atmosphere would have released a large amount of gaseous components that would have destroyed the ozone layer and altered the atmospheric composition of the Earth. We will now take a look in more detail at the intersection of circles 3 and 5. This image shows the overlaps of circles 3 and 5. The mechanism for the formation of overlapping rings would be similar to the intersection of circular ripples created from multiple objects dropped in quick succession into water. The interaction of the circular waves provides evidence that the events that formed the overlapping circles happened while the surface was molten. The center of Circle 3 is just inside the edge of Circle 5, and a splash zone outside of Circle 5 is highlighted. The impact for Circle 3 happened after the rim of Circle 5 had reached its final position and solidified, but when its surface was still molten. The rim of Circle 5 acted as a barrier over which some molten lava splashed from Impact 3. The fact that the center of the splash zone is closest to the center of Circle 3 is a strong indication that the force that caused the splash originated at the center of Circle 3. This video shows the formation of a splash zone. Experiments of impacts on liquids with different viscosities can be used to interpret meteorite cluster impacts that liquefy the impact area. An impact on a liquid can produce two splashes. The first splash occurs when a cavity is made as the object penetrates a liquid. The liquid rebounds to fill the cavity and creates a column of liquid that collapses and creates a second wave and a new splash. The rings of the Aïr Mountains could have resulted from the impacts of a cluster of meteorites originating from a comet that disintegrated in the Earth's atmosphere. The good news is that due to their elevation, the sand of the desert has not covered these interesting circular geological features. Geologists will need to date the rings and find evidence of shock metamorphism to prove that an extraterrestrial impact occurred and perhaps triggered the Snowball Earth cooling event. The bad news is that in addition to the hazards of the desert, this region of Niger is very dangerous. Death can come from the harshness of the land and from its human inhabitants. There are many smugglers and militia that kidnap people for ransom. On October 4, 2017, 4 U.S. Army personnel and 5 Nigerian soldiers were killed in an ambush by jihadist militias. Any geological expedition will have to be accompanied by a large number of armed security guards. More likely, the rings of the Aïr Mountains will keep their secrets until there is peace in the region.